All right, so today we're going to be talking about the periodic table. If this will load. There we go. Our objectives for today are to understand the arrangement of the periodic table, so how and why they're in this order. Also to identify elements as whether they are metals, nonmetals, or metalloids or semimetals. And then also to determine the number of valence electrons in an atom, which will also play a role in something called ions or formation of ions. So let's talk about a brief history of the periodic table. So scientists studied the properties of elements to figure out the best way to organize them. So the first person to make a recognizable periodic table, one that was usable and able to expand as more elements were discovered, was Dmitry Mendeleev. He was Russian, and this was developed in 1869. Now, his periodic table organized the atoms of elements according to atomic mass. Now, that's different from the table that we use today. The modern periodic table we use today, it has our elements arranged by atomic number, and the person responsible for arranging that periodic table was Henry Moseley. Okay? So when our elements are arranged by atomic number, this allows elements with similar properties to appear at regular intervals. So our groups are going to come together based on similar properties. So those columns are going to appear and the elements in them are going to all have similar properties. Okay? Now, the difference between arranging by atomic number and atomic mass wasn't huge, but there were a few discrepancies whenever it was arranged by mass that arranging them by atomic number did fix. Because if you look closely at the periodic table, all right, so if we take a brief look at the periodic table, there's a couple instances where some of the masses, if that's how we were to organize them, they would not be in order, and the properties that these display wouldn't match up with the group that they're in. So argon, if we look closely, I'm going to zoom in a little bit. Here we go. Argon, you can see it has an average mass of 39.948. And potassium has an average mass of 39.098. If we were to switch places with those, potassium does not behave the same as these other noble gases. So it wouldn't be a good fit. So that's why using atomic number is a better choice than atomic mass. Another example would be cobalt and nickel. And if you look closely, you may be able to find a few more examples in the periodic table as well. All right. So let's get back into our notes. Okay. Move myself down there. All right. So elements are arranged in order of increasing atomic number so that elements with similar properties are going to be in the same column or group. We also call these families. There are 18 groups on the periodic table. So groups, remember, columns are up and down. I think of like Roman and Greek architecture. Columns in that, those are those vertical columns, right? They're up and down. So that's a good way to remember that a group or a column goes up and down. Okay. Periods are going to be the rows. They're side to side. Okay. There are 7 periods on the table. And as you move across a period, so as you move from left to right, elements are going to become less metallic. So remember, metals are shiny or lustrous. They are good conductors of electricity and heat. They're typically malleable and so on. So as you move across, those properties decrease. Okay. So group, you can see here, up and down, that's a column, and periods are the rows that move across side to side. Okay. So groups, elements in the same group have the same number of valence electrons. Valence electrons are going to be the electrons we find in the outermost shell of an atom. So here we have a helium atom. I know this is helium because I have 2 protons, and number 2 on the periodic table is helium. This is its outermost shell, and helium is special because it's a noble gas and it's in group 18, even though It only has 2 electrons. Now we justify putting helium there because it behaves as a noble gas, and even though it doesn't have the same number of electrons, it does have a full outer shell like most of the other noble gases. Okay. If we look across, there is a pattern to the number of valence electrons. Group 1 and group 2 are going to respectively have 1 and 2 valence electrons. So group 1 has 1 valence electron, group 2 has 2 valence electrons. And then if we skip over this transition metals section, which has its own kind of set of rules for valence electrons that you'll learn in future chemistry classes, we get over here to groups 13 through 18, or we also call them 3A, 4A, 5A, 6A, 7A, and 8A. Okay, these groups are going to have the same number of valence electrons. Group 13 or 3A will have 3 valence electrons, 4 will have 4, and so on. Okay, we're going to pause here and then we'll talk about different types of elements. So metals, nonmetals, and metalloids next.